In these next few videos, we will learn the basics of object-oriented programming. We've seen the basic int, float, and string types and operations we can perform on them, such as the mathematical operations on numbers. We can write programs using many separate variables that represent something more complex, but it would be more convenient if we could compose or build more complex types by combining multiple values and provide operations on these grouped values. We call these grouped values objects. Most computer programs are written using an object-oriented approach, and this concept of composition is one of the more important concepts of object-oriented programming. An object is a collection of data, along with operations commonly known as methods for operating on the data. For example, we could have a person object, and it could use a combination of 9 strings, the first name, the middle name, last name, suffix, street address, city, state, zip, and date of birth. The reason we would use a string for the zip code is that zip codes can start with a 0. In practice, we would probably make an object for storing addresses that would consist of 4 strings for the street address, city, state, and zip code, and an object for the date of birth that would consist of 3 integers for the month, day, and year. The person object would then be a combination of 6 pieces of data, the 4 strings for the name, an address object, and a date object. Here are some possible methods for a person object. We could print an address label, and we could calculate a person's age. In the code example, we create person objects by using the name of the object and sending it the data with which to initialize or construct the person, and assign the result to a variable. We could then call a method named age. When we call it with John, it uses John's date of birth to compute his age, and when we call it with Jane, it uses Jane's date of birth to compute her age. Object-oriented programming has a number of benefits. One is reusability. We could reuse the date object we create for the person in other code that needs to use a date. Another benefit is the programmer using the object doesn't need to understand the details of how it is implemented. Someone using the object only needs to know how to use the methods. This hiding of details is known as abstraction. Just as we do not need to understand how zeros and ones are used to represent integers in Python in order to use them, we do not need to understand how the age method calculates the age of a person. We just need to know how to use the age method and what it gives us. Possible options it could give us are an integer representing years, a float representing years, or 3 integers indicating the number of years, months, and days old. For now, we are going to learn how to use objects that someone else has written for us. Later, we'll learn how to write our own objects. The book includes a set of graphics objects to introduce the concepts of object-oriented programming so we can draw shapes on the screen. We'll start by introducing a 2-dimensional point object. The data for a point consists of its x-coordinate and y-coordinate. To support drawing on the screen, the point class has additional data for an outline and fill color, but we will ignore those details for now. The term class is typically used to refer to the type of an object, and class names are capitalized by convention in most programming languages. An object whose type is that of a specific class is also known as an instance of that class. In Python, objects are constructed using the name of the class, followed by parentheses. Any information necessary to initialize the object is placed inside the parentheses. We usually assign a variable to the expression that constructs the object, so we can store the object for later use. We construct a point by calling its constructor with 2 numbers representing the coordinates and assign p1 to the result. Now p1 is a point object, or we can say p1 is an instance of the point class. Here is a description of some of the point methods. We have the constructor, methods for returning the x and y coordinates, a method for moving the point by a specified amount, and a method for making the clone or a copy of the point. Remember, objects combine data and the methods for operating on them. When you call a method, you must indicate which object's data that method should use to perform the operation. In Python, this is done by writing the variable name, a period, the name of the method followed by parentheses. Any additional information for that method is placed inside the parentheses. Here's the Python syntax to use the methods we described on the previous slide. First, we create a point named p1. Next, we call the getX method using p1's data, so p1x would be 2. Calling the getY method using p1's data returns 3 and is assigned to p1y. The move method does not return a value, so we have not assigned anything to it. Instead, it mutates the object, so its coordinates are now 6 and 8. p2 equals p1.clone creates a new point object with coordinates 6 and 8. Now we'll look at what happens internally in Python when you create objects to help you understand how they work and how to use them properly. Here we create a point object with x-coordinate 2 and y-coordinate 3 and assign it to the variable p1. Python stores an object in the computer's memory, indicating the type of the object and the data for that object. Next, we create a second point named p2, and another object is created in the computer's memory. Now we call the methods on the variables by using the variable name, the period, the method name, and parentheses with any additional information necessary for the method inside the parentheses. The getX method does not need any additional information, it just returns the x coordinate for that point. When we call it with the point p1, Python uses the data for the point p1 and we get back 2, which is stored in p1x. When we call p2.getX, we get back 4, since that is p2's x coordinate. Note the getX and getY methods do not change the data for the points. Now we'll start with these same points, but now we'll call the move method. The move method is a mutating method as it changes the data for p1. The move method takes 2 additional pieces of information that indicate how much to add to the x coordinate and how much to add to the y coordinate. When we execute it, the data for p1 is updated accordingly. Now when we call the getX method using p1's data, it returns 8, which is stored in p1x. If we call getX with p2's data, we still get back 4, since we didn't call a method to change p2's data. Let's do another example starting with the same points. This time we'll assign p3 equals p1. As you recall from the earlier videos, when you assign one variable to another, both variables refer to the same data. This does not create a new point. Instead, we have 2 different variable names that both refer to the same point object. Now if we call the move method with p3, that object is changed. Since p1 refers to the same object, if we ask for p1's x coordinate, we get back the updated value of 8, as we would if we call it with p3.getX. p2.getX would still return 4. Let's create p1 again. When we call the clone method using p1, we get a separate second point that has the same data as p1, and we've assigned that to the variable named p2. Now when we call the move method using p2, it mutates the point object that p2 refers to, but since p1 is a separate point, p1 does not change. We can check this by calling p1.getX and we get back 2. Calling p2.getX returns 7.